Hi everyone, myself B. Praveena. I'm the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about the topic on Rolle's theorem, the problem. For that, what about the statement of the Rolle's theorem? Okay, Rolle's theorem comes under mean value theorem. First, I'll discuss with the Rolle's theorem statement. Let f of x be a function such that it is closed interval continuous in sorry it is continuous in closed interval a comma b, and the second one, it is differentiable in open interval of a comma b, and it is f of a is equal to f of b. Okay, if the three conditions satisfied, okay, then there exists at least one point on C in open interval a comma b such that f dash of C is equal to what? 0. F dash of C is equal to 0. Already we discussed in the last class what is continuity differentiability. Okay, na? Then, okay, you have to apply that concept there. If it is continuous in given function is continuous in closed interval a comma b, and it is differentiable in open interval a comma b. And the third point, if f of a is equal to f of b, if the three conditions satisfied, okay, then there exists at least one point C in a b such that whatever that f dash of C is equal to 0. Okay, from that we get one point of C. Okay, this is the statement of the Rolle's theorem. Now I want to discuss about the problems. Okay, using Rolle's theorem show that g of x is equal to 8x cube minus 6x square minus 2x plus 1 has a 0 between 0 and 1. Okay, show that g of x is in between 0 and 1. That means using Rolle's theorem we have to find that c value. Okay, from that, here once observe the given polynomial. Here the function is in polynomial form, right? If the polynomial means definitely, if the function is differentiable means definitely that function is continuous. Okay, that function is continuous. Once observe there, here g of x is equal to, okay, 8x cube minus 6x square minus 2x plus 1 being a polynomial. It is continuous on closed interval 0, 1, and it is differentiable on open interval 0, 1. Okay, I'm going to first I have to verify is it differentiable or not. From one of the property, if the function is differentiable means definitely it is continuous, but converse may not be true. Okay, but here the given equation is one polynomial, so that definitely it is differentiable. If it is differentiable means definitely it is continuous. Okay, how we are verifying that? First of all, here g of x is equal to 8x cube minus 6x square minus 2x plus 1. And that what about g dash of x? G dash of x is equal to 24x square minus 12x minus 2. This is the differentiation. Okay, if the function is differentiable means definitely that function is continuous. This is one from one of the property. Therefore, here this is continuous. Therefore, it is continuous. Differentiable. Therefore, g of x is differentiable in closed in open interval 0, 1. Okay, if it is differentiable means from one of the property, then the given function g of x is continuous. G of x is continuous in closed interval 0, 1. Therefore, here two conditions satisfied, right? Here two conditions satisfied. For that, we have to verify the given interval, whatever the given interval here, 0 and 1. In between 0 and 1, we have to verify g of 0 value is equal to g of 1. For that, whatever g of 0, here g of 0 means whatever the given polynomial is, 8x cube minus 6x square minus 2x plus 1. Substitute there, that is, this is equal to 1. G of 0 is equal to 1. And what about g of 1? Similarly, G of 1 is equal to, that is 8 into 1 cube minus 6 into 1 square minus 2 into 1 plus 1. That is 8 minus 6 minus 2 plus 1. These are cancelled. Then directly it is equal to 1. Therefore, G of 1 is equal to 1. Therefore, here G of 0 is equal to G of 1. That means here three conditions are satisfied. One is differentiable and another one is continuous, and another property G of 0 is equal to G of 1. These three conditions satisfied. If the three conditions satisfied, if there exists a number C belongs to 0 comma 1 such that G dash of C is equal to 0, such that G dash of C is equal to 0. From that, what about G dash of X here? That is, this is G dash of X, that is 24x square minus 12x minus 2. Okay, from that here I'll take 2 outside. G dash of X is equal to 0. From that I'll take 2 outside, that is 12x square minus 24, 2 12s and 2 6x minus 1 is equal to 0. 12x square minus 6 minus 1 is equal to 0. From that, find the roots of this. Okay, for that here I'm using minus b plus or minus under root b square minus 4ac by 2a formula. There, what about minus b? Minus b means here minus 6. That means minus of minus 6 plus or minus under root minus 6 whole square minus 4 into what about a 12 and 1, 12 and minus 1 by 2 into minus 1, 2 into a, that is 12. 2a means here 12. Okay, from that after simplifying that, after taking common there, plus 6 under root 36 minus plus 48, 12 for the 48 by 2 into 12, 24. Okay, here I am taking 3 outside. From that, after the cancellation, directly here we get 3 plus or minus root 21 by 12. 3 plus or minus root 21 by 12. From that, here we get two roots. First one, 3 plus 21 by 12. And the second one, 3 minus 21 by 12. 3 plus 21 by 12, and another one is 3 minus 21 by 12. Okay, by using the calculators directly in the decimal value for that, 0.63 and minus 0.132. Therefore, which is in between the given in interval limit points, and that is 0 comma 1. Only here 0 comma 1 means that all values comes under the positive. After getting the root values, which is positive 0.63. Therefore, in between 0 comma 1, 0.63 is lies in between 0 comma 1. Therefore, there exists at least one root, one point C belongs to AB such that f dash of C is equal to 0. Therefore, here C is equal to 0.63 belongs to 0 comma 1. Therefore, Rolle's theorem verified. Rolle's theorem verified and C is equal to 0.63 belongs to 0 comma 1. This is the concept for by using Rolle's theorem we have to verify the function is satisfied Rolle's theorem conditions or not. If it is satisfied means then you can find C value. From that here we get C is equal to 0.63. Next, verify Rolle's theorem for the function f of x is equal to x power 2 by 3 minus 2x in power 1 by 3 in the interval 0 comma 8. Once observe the given function, here f of x is equal to x power 2 by 3 minus 2x power 1 by 3. Is it one polynomial form? Right, it is also one polynomial form. We have to verify the values. We have to verify the Rolle's theorem between the interval is 0 comma 8. That is function, this is f of x, and f of x is continuous in 0 comma 8. And what about the Rolle's theorem conditions? F of x is continuous in closed interval a comma b, and f of x is differentiable in open interval of a comma b, and f of a is equal to f of b. If the three conditions satisfied, then there exists one C belongs to AB such that f dash of C is equal to 0. Here, what about the function f of x? This is f of x, and once we have to verify the function is continuous. Okay, before verifying that continuous, first we have to verify is it derivable or not. If it is derivable, means from one of the property, this is definitely continuous. For that, I am verifying the derivation part of the given equation. F of x is equal to x power 2 by 3 minus 2x power 1 by 3. That is, what about the derivative of that? X power 2 by 3 means x power n formula, n into a power n minus 1. That is 2 by 3 into x power 2 by 3 minus 1 minus 2 into 1 by 3 into x power 1 by 3 minus 1. That is 2 by 3 into x power minus 1 by 2 minus 2 by 3 into x power minus 2 by 3. That is here 2 by 3 common. I'll write it as this 1 by x power 1 by 2 minus 1 by x power 2 by 3. 1 by 3 there. 1 by 3 minus 1 by x power 2 by 3. Okay. This is the derivation of the given function f of x. Is it derivable or not? Definitely it is derivable. So that if it is derivable means definitely the given function is continuous. That means if therefore f of x is derivable in closed interval, open interval 0, 8, so that f of x is continuous. Continuous in open interval, closed interval 0, 8. Then two conditions satisfied. Now we have to verify the function as f of 0 is equal to f of 8 or not. Okay, for that, what about f of 0? Here the interval is 0, 8, so that we have to verify f of 0 value, that is 0 power 2 by 3 minus 2 into 0 power 1 by 3. This is 0. And the f of 8, that is 8 power 2 by 3 minus 2 into, 0, 8 power 2 by 3, right? And 8 power 1 by 3. That is 2 cube into 2 by 3 minus 2 into 2 cube into 1 by 3. There 3 cancel. 4 minus 2 to 4. That is 0. Therefore, f of 0 value 0 and f of 8 value 0. F of 8 value 0. Therefore, in that both the cases, that within the limit points 0, 8, f of 0 is equal to f of 8. The two are equal. Now, from that conditions, f of x is differentiable and f of x is continuous and f of 0 is equal to f of 8. Therefore, all the three conditions are satisfied, so that if there exists C belongs to AB such that we have to find the C value. That is f dash of C is equal to, there exists at least one point of value of C in 0, 8 such that f dash of C is equal to 0. F dash of C is equal to 0. From that, what about f dash of C? That is this is f dash of C. That is 2 by 3 into 1 power x power 1 by 3 minus 1 by x power 2 by 3 is equal to 0. From that, 1 by x power 1 by 3 by 1 by x power 2 by 3 is equal to 0. That means if here, okay, there C belongs to AB such that means here 1 by C power 1 by 3 minus C power 2 by 3 is equal to 0. From that here C is equal to, after simplifying the 2 here, C value is equal to, okay, C value is equal to 1. Okay, C is equal to 1. Therefore, okay, once observe here 1 is in between 0, 8 or not. This is in between 0, 8. Therefore here the Rolle's theorem satisfied for the given polynomial x power 2 by 3 minus 2x power 1 by 3. X power 2 by 3 minus 2x power 1 by 3. This is the concept for by using Rolle's theorem we have to verify the polynomials. Okay, within the interval either 0 comma 1 or 0 comma 8. Okay, once again I'll repeat. What about the Rolle's theorem concept? Rolle's theorem very simple. If there any function is satisfied, it is continuous in closed interval a comma b, and it is differentiable in open interval a comma b, and f of a is equal to f of b if the three conditions satisfied, if there exists at least one point c belongs to ab such that f dash of c is equal to 0. Once observed, now we discussed two questions. In the two cases, the two are okay verifying the concept of the Rolle's theorem. The two are polynomials only, so that the two are verified, and that c value also in between the given limit points. First one is 0 comma 1, and the second one is 0 comma 8. Okay, this is the concept for the Rolle's theorem. Next class we will discuss with some other concepts of the third unit. And once observe this Rolle's theorem concept comes under the functions of single variables. Once observe in the function f of x means here the function is x a single variable, and there also function is in single variable. That means Rolle's theorem and the next okay mean value theorems, how many? Three are there. First one Rolle's theorem, next one Lagrange's theorem and Cauchy's theorem. These three are comes under functions of the single variables. So that now we discussed Rolle's theorem concept. Next class we will discuss with the Lagrange's theorem and the Cauchy's theorem for the single value functions. Okay, this is the concept. Okay, thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.